Hello, I am Gargi Bhosle from Group 6 and I'll be talking about machine translation with BLEU. BLEU, which is a short form of Bilingual Evaluation Understudy, is an algorithm that was originally developed to measure machine translation. Machine translation is automated translation. It is the process by which a computer software translates text from one language to another. Now, BLEU is one of the most popular algorithms to evaluate the quality of output text which is being translated from one language to another. Need of machine translation. With increasing amounts of data being added every day in a particular language, it takes weeks, sometimes months, for humans to translate them. But with the help of machine translation, it can be done inexpensively and in a very short time. We see that machine translation can be text to text or text to speech also, which adds to one of many quirks of machine translation. Now, we see an illustration. Consider a sentence in German, Ich esse 4 Erdbeeren. Now, some given reference English translations are, I am eating 4 strawberries or I eat 4 strawberries. Now it is required to assign a single numerical score to this translation that tells us how good it is. Now we talk about a measure called as unigram precision. We see an algorithm for it. We consider each word in the output sentence, that is the translated sentence, and assign it a score of 1 if it shows up in any of the reference sentences and 0 if it doesn't. Now, we divide the number of words that showed up in one of the reference sentences by the total number of words in the output sentence. To clear this, we take an example. Consider a sentence, I eat 4 strawberries. And it is given that all the words in the output sentence are in the reference sentence. So, the number of words that showed up in the reference sentence are all of them. That is the total number of words, which is 4. And now, using the above given formula, we divide them with 4. That is the total number of words in the output sentence, and hence get the final score as 1. Now, if we consider other example, the given sentence is 4, 4, 4, 4. Here, using the above logic, we know that 4 is in the reference sentence, and hence, if we use the above formula, we'll get the final score as 1. But we observe that this translation is worst and it makes no meaning. So, thus arises a need for n-gram precision. Now, the previous problem can be solved by counting not the individual words but the words that occur next to each other. Now, these are called as n-grams, where n is the number of words per group. Unigrams, bigrams, trigrams and 4 grams are made up of chunks of 1, 2, 3 and 4 words respectively. Now, we see a n-gram precision example. Here we have 2 candidate sentences that are the sentences which are obtained as output from the model, that is the translated sentences by the machine translation algorithms. And for comparison, we have 3 reference human translations of the same sentence. Now we use n-gram in this, and how it is used is we just count the number of n-gram matches from the candidate sentence and the reference sentences. These matches can be position independent and can be matched multiple times to the reference. Now we consider the candidate 1, that is the first sentence which is obtained as output. Candidate 1 shares many words and phrases with these 3 references. We observe that candidate 1 shares, it is a guide to action with reference 1 here, which with reference 2, ensures that the military with reference 1, always with reference 2 and 3, commands with reference 1, and finally of the party with reference to. So we see that n-gram precision is 17. Here n-gram precision is the total number of words that are matched with the references. In the candidate 2, we see that there are far fewer matches than the candidate 1 and the n-gram precision is 8. That is, only 8 words from the candidate 2 are matched by the reference sentence. Now we see modified n-gram precision. The procedure is given here, and now we consider a candidate key, that is the candidate sentence, as the being 7 times. So we see there are 2 references provided here, that is the cat is on the mat and reference 2 is there is a cat on the mat. So we follow a procedure, that is count the max number of times a word occurs in any single reference. So we consider the reference 1 and we observe that the word the has max count 2. Now we clip the total number of each candidate words. We observe that the unigram count is 7. That is, the counts of words in the sentence, in the candidate sentence is 7. There are 7 times the. And the clipped unigram count, that is the maximum number of the which is occurred in the reference 1 sentence is 2. And we see that the total number of count is 7. Now, modified n-gram precision equals to the clipped count upon total number of candidate words. So we see that the clipped unigram count is 2. So 2 divided by the total number of count, that is 7. So this is the modified n-gram precision. So this was all about the n-gram and the modified n-gram precisions. Now we see the issues with the BLEU. We see that BLEU doesn't consider the meaning. That is, it only rewards n-grams that have exact matches in the reference system. That means that a difference in a function word like an or on is penalized heavily as a difference on a more important content word. As humans, we know that the words an or on are not that important for the translation. As long as the meaning is conveyed, it is perfectly fine. The other issue with BLEU is it considers only sentence structure. For example, take a sentence, I saw the dog with the telescope. Now this sentence can either mean that I was using the telescope to look at the dog, or the dog had a telescope. Now, to automate the modeling of this kind, structure parsing is there. But BLEU, unfortunately, doesn't build on any parsing techniques. Other issue with BLEU is that it measures direct word-by-word similarity. So these were the issues with BLEU, and this was all about the machine translation with BLEU. Thank you.